Hello, thank you for joining me. I want us to look at bitwise operators. Now, bitwise operators are critical in JavaScript, and we want to look at them and get to know how they can be used. Now, we are talking of bitwise operators. JavaScript is able to support the following bitwise operators. We normally have bitwise and, bitwise or, and we also have bitwise XOR, and we also have bitwise not. So those are the bitwise operators that we want to go through and get to know exactly how they can be used in and how they can be used in JavaScript programming. Now, moving on, we talked of other operators. We talked of the logical operators, and also we looked at relational operators before. Now, there are assumptions that we need to make in order to understand this idea that I'm presenting to you. So as you have noticed, we always go through some notes, get to understand the knowledge behind the item or the idea that I'm putting across. Thereafter, we'll go into the practical aspect of what we are looking at. So I have here with me two variables. So the first variable is A and the other variable is B, and these variables have got some data in them. So the A variable, or the variable called A, holds 2, and the variable called B holds 3. Now, when using a bitwise AND, we are told that, as you can see from the screen, that it performs a Boolean AND operation on each bit if it is integer arguments. Okay, so for example, we have A and B, or A bitwise AND is 2. Then we also have bitwise OR, which is able to perform a Boolean operation on each bit of its integer arguments. Right, so we have A bitwise OR, it will be 3. Then we have bitwise XOR. Now it performs a Boolean exclusive OR operation in each bit of its integer arguments. Now, exclusive OR means that either operand 1 is true or operand 2 is true, but not both. So that is important to take note of that. Then we have bitwise not. So it is a unary operator and operates by reversing all the bits in the operand. So it's able to reverse B in both, and then you will have 4, right? So there is also the shift left. So it moves all the bits in the first operand to the left by the number of places now specify in the second operand. New bits are filled with zeros. Shifting value left by 1 position is equivalent to multiplying it by 2, and shifting 2 position is equivalent to multiplying it by 4, and so on and so forth. So A shift left 1 is 4. Then he is like multiplying 2 by, remember A had 2 in it, so this means you multiply it by 2. So if you take 2 times 2, you get 4. Then this binary right shift operator, the left operand value is moved right by the number of bits specified by the right operand. So this one will give you 1. Then there's also shift right shift left with 0. So this operator is just like shift right operator, except that the bits shifted in on the left are always 0. So let's look at the example of this and basically try to do them practically and get to see how they work. Okay, so we are going to start with the we are going to start with a we are going to start with the bitwise and. So if we head to our code section, now we are going to change the values here. So A had 2, B had 3, and so we have the bit presentation what I'm going to do here is I'm going to eliminate some of this so that I'm left with what I can manage. So this example is going to work this way. I'm going to have as part of what should be shown on the screen, it will be this. Then I should have that in there. This should appear within some kind of brackets so that it looks like what it should be. Then we are going to have some result here. So the result is going to be this A and B. So it is a bit, as you can see. So this is the bitwise and. So I'm trying to implement it here, and these are the lines of code that I've been able to write so that we are able to see clearly what we are talking about here. So let's go live and see the result on the browser. See the results on the browser so that we can ascertain that we are doing the right thing. Yeah, there we have our result. So as you can see, we have A and A bitwise and will give you 2 as we had stated earlier in the notes. Now let's try to implement the second bitwise or. So for the sake of time, I'm going to copy this and technically do it down here. so this one is going to be okay, so this one is I'm going to change to be logical, or sorry, so it should be this. Therefore we have the result there. So if we save this and get to see the result, 3 right there. So as you can see, this is the outcome. So the first one is the bitwise, and the second one is the bitwise or. And then we move on to the next one. So the next one is what we call bitwise XOR. So we are looking at bitwise XOR. So we try to implement it here. So we are going to copy this, have it pasted below the code that we already have. Then we change a few things like what we are doing here. B as well. This one should be B as well, so that we should be B. So here we're going to change this to be that simple there. We save that. So our result will have changed here. Let's see what we've got. Yes, so as you can see, these are the results. So as you can recall from the description we had, perform a boolean or operation on each bit if it is integer, right? That is the bitwise or. Then we have the bitwise XOR, perform boolean exclusive operation on each bit of its integer argument. Exclusive or means that either operand is true or either operand 1 is true or operand 2 is true, but not both. So it should be 1, should give you 1. Then we move on to the other operator. We move on to the other operator. So when we go back to our code here, we'll do this and copy this here. This time we are going to remove this, so we're going to have that. Then here we are going to remove that and have this symbol preceding our B, and therefore we save and we go through the browser so that we can be able to clearly see what is the answer there. So we see we are getting -4. Okay, then the other thing we need to look at is shift left. Yes, so we need to shift left. So let's see what will become of our shifting left of elements. So let's go back to the code and we look at the shift left. So we copy So we have A, and we do this, and also here we have A, and we do that. And let's see what we've got on the browser. So let's have a look at what we have on the browser right here. Okay, so we have 16. Okay, so it's like multiplying the number 2 by 4 or 8 times. So what if we change the symbols and have the reverse of what we already have? So we copy this and paste it here. So this is what we call shift right operator, binary shift right operator. That is what we want to look at this level, just to see the result, what will become of it. So if we save that and we go to a browser, we'll be able to see a 0, right? So because we are shifting right. So the next element is, I think that is the last one. So we've gone through various operators. We also need to look at assignment operators, but that one will do it next time. So for now, thank you for joining me and taking your time to listen and to take your time to advance your knowledge on this. Thank you.